Welcome back. This session we will see another powerful concept in this object-oriented programming, that is abstract class. So an abstract class includes data and methods common to its subclasses, but the specialty is that an abstract class can never be instantiated. So we cannot directly create an object for an abstract class. Instead, it will hold all the common data, common properties or common behavior and common methods for its subclasses. Just for example, here we have an account in which two subclasses are the saving account and checking account. There can be lot many attributes or properties which are common for both saving account and checking account, right? And also there can be a set of methods or functions that is also common for both savings account and checking account. So instead of defining all these common things in both saving account and checking account, those common data and properties, that is common methods and properties, can be defined within this parent class, and this saving account and checking account can act as an extension for this account parent class. Extension means all the methods and behavior, that is data and functions, okay, those can be inherited by these two subclasses, and then they can have their own implementation for those methods, and they can define their own specific attributes and methods in those classes. Okay, so what are the specific attributes and methods which is specific to this saving account? It can be defined here. Like that, all those specific data and methods which is specifically for this checking account can be defined here. Other common things can be inherited from this account. So you may think that we have already seen this subclass, superclass, inheritance and everything, right? So what's the difference between those normal subclass, superclass and here in this abstract class? Of course, the difference is that abstract class cannot be instantiated. So why there is such a restriction is that in the case of abstract class, most of the methods are actually unimplemented. That means only the declaration of the methods will be there in the abstract class. Okay, and the corresponding implementation. Declaration means that prototype, header part will be there. What is the function name? What are the arguments? Only those things will be there in the abstract class or super class, and the corresponding implementation of the method. Implementation in the sense the definition of the corresponding method will be up to the corresponding subclass. So each subclass can have their own implementation. Okay, so the subclass which implement this method can be called as the concrete class. So in our example, saving account and checking accounts are concrete classes, whereas this account class is a abstract class. So unlike concrete class, an abstract class such as account is never instantiated. Okay, so we can call this abstract class as blueprint for other classes, and it allows to create a set of methods that must be created or defined within any child class built from the abstract class. So any class which contains at least one abstract method can be called as abstract class. So abstract method in the sense that method declaration will be there in the parent class and the implementation will be left up to the child class. And we are designing a large functional units, we can use this type of abstract class. That means a lot of subclasses are there, and each of which are having some common methods, and implementation of the method is depending on the corresponding subclass. In that case, we can define all those common methods in the abstract class, and this is mainly useful when the implementation of the corresponding method is up to a third party. So only the declaration will be defined by the programmer and the implementation is left to the third party. So when we want to provide a common interface for different implementation of a component, we can use this abstract class. Now let us see how this abstract class works, how we can define a class as abstract like that. By default, Python does not provide abstract classes. Instead, we have a module in Python. Python comes with a module that provides the base for defining abstract base classes, and the module name is ABC. So if you want to define an abstract class, we have to import this module. ABC works by decorating methods of the base class as an abstract method, then registering concrete classes as implementation of the abstract class. So a method becomes abstract when decorated with the keyword abstract method at abstract method. So we'll see an example. First we have to import this module ABC. Then we have to define the corresponding abstract class by mentioning that it is a parent class for that abstract class is ABC. Then we can define some of the method within the abstract class using this decorator keyword at abstract method. We will see an example for that. Here we have a abstract base class work. See this class polygon. That's an abstract class. So what we are doing before defining the abstract class, we are importing this module from the package ABC. We are importing the module ABC, capital ABC, within which we have the definition or the base for this abstract class method, and we are also importing this decorated abstract method corresponding definition also we are importing. Now we are creating a new abstract class, that is polygon, and mentioning that ABC is the parent class for this polygon because all the base abstract class definitions are there in ABC. Now we are saying that within the polygon we have a method which is abstract. How we can specify that? Using this decorator at abstract method. And you can see that there is a method name, number of sides, and we don't have any specific arguments, only the self is the argument. See that pass is the only code here. That means we are not defining this method here. That is up to the corresponding subclass. So that is why we are putting a pass here. So this is an abstract method. Another subclass for this polygon. You can see that triangle is a subclass by mentioning that polygon is the parent of this subclass triangle. And within that what we are doing, we have already this number of sides inherited from the polygon parent class, right? Yeah, here we are defining it. Okay, so actual implementation of this number of sides method is there in the triangle subclass. Here we are printing I have 3 sides. So overriding abstract method, already we have the method in parent class. It is defined as abstract there. That means there is no implementation in the parent class. It is up to the child class. And here we are redefining or re-implementing the corresponding method. So we can call it as overriding. So we are defining the corresponding method here. Another class also there, subclass pentagon, which is also a subclass of polygon. There also we are overriding or implementing the corresponding number of sides method. I have 5 sides. So a hexagon is there, quadrilateral is there. Every one is subclass of this polygon class. So everywhere we have, you can see that new definition for the corresponding number of sides. Okay, so all these 4 different classes are concrete classes in which we have the implementation of the corresponding abstract method, and we have this polygon as the abstract method. So these are the different definitions. Now we are invoking the corresponding class objects. So we cannot directly instantiate the polygon class because it's an abstract. Okay, so other subclasses, that is concrete subclasses, we can directly instantiate. So for triangle we are creating an object R and we are calling this R dot number of sides. So it will print I have 3 sides. Then we are creating an object for a quadrilateral and call the same method there, K dot number of sides. I have 4 sides will be printed. Like the for pentagon and hexagon, we are creating an object and calling the corresponding number of sides. The corresponding method with, defined in the corresponding subclass will be invoked. So this is abstract class. These are the different references for this. Thank you.